There we go. Everybody should have got the notice that it's being recorded and broadcast right now.
Well, it's actually, wait a second. Why did it? Somebody could go to YouTube and check it. But
Well, Zoom thinks you're doing it.
Speaking of Zoom, they did have a recent update yesterday, I think. So Zoom is now up to 5.14.5 for all devices, Apple devices at least. So if you haven't updated, don't worry about it because it'll require you to leave the meeting and come back. But it's usually a good thing to do that just before you come to the meeting. Not that it makes a lot of difference because usually it's stable for, I think it's stable for quite a long time. In Ventura, if you're running it, is at 13.3.1 and the OS is at 16.4.1. So hopefully your Apple devices are all up to date to keep this security present. Yes, Mike, go ahead.
Yeah, I just told Zoom to check for update, and it came back with 5.14.5.17687.
What?
So I guess there was, I know that the .5 release did come out Tuesday, I think. And I had not used Zoom on my MacBook, since before that. So I figured I'd just check this morning, and it says, yeah, that I had 5.14.2. And I figured, okay, it's just going to go up to .5, but then, that additional, patch reference after that.
Oh, so they must have had something they had to correct there, but yeah, I had some notice the last time I logged into Zoom. It wanted me to accept something. I have a free account, one free account in the personal account, and it had me accept some new rights or new agreements to whatever it was doing. So, of course, never reading those things, it probably says now it's going to start charging me or something. But it is getting, if you do have a free account, it is rather annoying now. It's like kind of bugging you a lot to upgrade. And one of those things that like the meeting kind of showed, it almost has a button that you might inadvertently click, but I don't think it would start charging anything because it doesn't have any cards on record. But so if you got a free account, so they still have the free account available for 40 minutes. The timer starts as soon as you connect. So it changed a few rules. It used to be that you could have 2 people and that it wouldn't start until 3 people showed up. And now it starts as soon as 1 person starts the meeting, the timer starts. So at the end of 40 minutes, it disconnects you, lets you connect again. But it's still a fairly reasonable free account if you want to have short conversations. A reminder that coming up in June, of course, is the Apple's Developers Conference, in which Apple makes a few announcements at the beginning, and you can attend the developer talks and presentations that are going to be on that. I think it's Monday, the 5th of June, but that's when it starts. And they usually let you go to any of the talks and listen to them too. So they stream those. They should be pretty good there. The other meeting coming up next week, we're going to have a giveaway meeting, a special extra added attraction meeting that Anne has arranged at her location. And we're going to be giving away or making things available that came from the cabinet that we feel the club no longer needs to keep. And I might have historical or useful, use for other members that want to come and get it for free. So I think we might have some old time machines there, some old cables, an old Apple clock. I think Jonathan knows more about what the things he's got, and I've got a few things here that I'll be taking that were in the cabinet. So, Ann, do you want to say anything about the location for the meeting? I know there's going to be parking available on the street, and there's also, it's close to the Tacoma Metro. So, is there anything else additional, Ann? People would just walk in, or we'll have more directions posted for the people. We have a poll at Groups.io. So if you are thinking of going, respond to the poll to let us know that you'll be there so that we can expect you.
Okay, well, hi, good morning, everyone. So let's see. Roy's already said it's Saturday, so the restrictions are lifted. You can park on the street, and you can also park at the Metro, which is about a block and a half from here. So it's the Tacoma Red Line Metro, and you would walk a block and a half south to get to our community. Put it in your GPS to get how to walk here. And let's see what else. And there is a bus. I don't know anything about the buses, but there is a bus that comes around here. You'll have to get that on get it through Metro. And I guess, let's see, did I post the address? I haven't posted the address, so maybe I'll put that in the chat now. Well, I can't because I don't think I can use the chat on my iPhone, but I can, I can't save the chat. That's right. Well, I'll put it in the chat, but we can put it out through Groups.io as well. We'll do that.
Yeah.
And this is a co-housing community. You're going to be, so it's sort of like when we visit Leisure World, you come into a community building and have your event. We'll be doing that. Our community building we call a common house. It's all the way at the back of the property. It's as far away from 4th Street. We're on 4th Street Northwest. It's as far away from the street as you can possibly get. So just look for the tower and walk toward the tower. And you see any of the neighbors, just ask directions. They'll know you're coming. So I'll announce. So be looking forward to seeing all of you.
Okay, that's great. And Bruce, I think you're planning on attending, right?
I am.
Okay, so if you got some little minor lightweight hardware to bring in and show Bruce, he'll be there. So, and it is a good time to meet up with people and show some of the device problems that you're having, because we can certainly talk about those. We probably are we're going to attempt to make it a hybrid meeting, and that should be working, but I don't know what hybrid communications will be like. So it'll be much better if you can show up and enjoy the meeting live rather than hybrid. So you might feel kind of left out hybrid, just watching what's happening with people that are there. Ann, go ahead. Ann, you have your hand up?
Just and unmute yourself, please. There you go.
That's a good idea. Unmuting myself, very important. But mine's a different topic. So I don't know if you're finished with this one.
I think so.
Okay, so today I go to groups.io to get the link into Zoom. And I'm doing this on my iPhone, and I'm wondering why those links are not hot links. I have to cut and paste them. I have to copy, cut and paste them into the browser, which is, a little bit of a pain to do on an iPhone. And so I'm wondering why they're not linked.
They actually can be hot links. It depends on how the person edits the posting, because you have to set it as a link. You have to highlight it and set it as a link. So it's just the fault of when we're posting them that we didn't make it a hot link. I think if you look in the calendar, if you go alternately to the calendar, the link there should be hot.
No, that's where that's the second place I went. I went from the message to the calendar, and that's where I still had to cut and paste it. That's one. And then in past announcements for the meeting, we have gotten emails that have the actual link in it. And then we get other links. Then we get other emails saying, if you want the link, go to groups.io or the TCS. Is that right? TCS calendar. go there.
Yeah,
So,
Yeah, TCS won't help you. That's pure text.
oh, I'm sorry, but it's, well, okay, it says to go 2 places. That's all I know. To go
Yeah.
2 places. And I'm wondering why we're not getting that extra email that actually has the link in it.
And may I?
Yeah,
Yeah, one of the things that we haven't licked yet, and you're talking about the exact issue, is that the calendar integration with groups.io could be smarter. So if Roy and I don't remember to put the actual link for the general meeting in the individual calendar event, then the calendar keeps sending you notices but doesn't include the link.
oh,
So this morning, I only noticed before I joined the meeting that I hadn't done that.
Mhm.
And so I sent another message around to everybody, with the link. But then that feeds into Roy's point that the links have to be individually a return in the email or in the groups.io to make it a hot link. And in the haste to do that, I sure don't think to do that. The last thing I would say is, one thing that Pi members can always do is when they first get a message with this, put that information into your own calendar, and it can, if you put it in the URL field, then it will be a hot link in your calendar.
Yeah, you're totally right about that. And it's just my, I'm just going through email so fast, but you're right. I mean, that's the best thing to do is just post it. And that link, I can't remember that link that we get. Is that new every time or is that a
Yes.
recurring meeting? It's
For
new
the
every time.
general meeting, it is. For the clubhouse, it's not. Clubhouse has been static for several
Mhm.
months now, so it's been working fine. And I think that one should be dynamic too. I was just looking at it. Let's see, Clubhouse. Yeah, the Clubhouse one is a dynamic link, and so
Okay, thank you, everyone.
But yeah, it's a problem with the way Groups.io takes the text, and unless you do designate, it's got a little hyperlink thing to edit it, but you've got to copy it and paste it again. So
I also should have said, I apologize for not acknowledging this. Thank you to Roy and John and anybody else who religiously make sure that we get announcements about meetings. It's really good of you to do that. So thank you.
right. All right. Yeah, speaking of automatic announcements, I mean, hopefully everybody's, been getting the automatic announcements that also get sent out by join it for when your membership expires. And if you have any problems with that, let us know. We try to correct the messages that get sent out to make it easy. Just as a reminder, if you remember in the old days, anything about connect.wap.org, don't click on that, don't use that. That completely short circuits trying to join it. It does make a connection to Stripe and you can make a payment, but it doesn't get recorded and join it, so your membership doesn't get extended. So but it is very easy to keep it going using join it, and then that does use the Stripe. So you should all be receiving automatic messages. And if you do have any problems, let us know. Okay. So how has the past week's been with everybody? Anybody have any Apple items of discussion?
Well, Roy, did we want to actually start out talking about the Apple Wallet new savings account and setting that up? That might be a good thing.
That's a good topic. Has anybody done it? I've seen a lot of things and I keep meaning to do it. Good. So does that go smoothly? You just go there and give it some money and it's off and running?
Yeah, there were two things I think that some Pi members noticed. The first was that in the initial rush for this, sometimes the wallet balked and didn't let you do it. And this was a classic dynamic of what sometimes happens after a major OS upgrade or iOS upgrade. Once that settled down, there was a small curlicue that that I noticed, which is that the Apple Cash in the new iOS iterations has required a identity proof because of the nature of Apple Cash, like some of the other electronic payments, that once the money leaves, you have no recourse. And so they want to be sure that you've connected all of your stuff and that you know what you're doing. And the way I found that out is that when I tried to transfer money from Apple Cash in my wallet to the new savings account, it didn't work. But finally, when I did the identity verification in Apple Cash, after that, it all worked smoothly.
Okay. Good words of advice there. Anybody else have any?
I
comments?
haven't yet added additional bank accounts or anything. I don't know that I will need to do that, but apparently it's fairly straightforward to link additional bank accounts to the savings account.
Now, why would you do that?
You might want to fund the savings account with additional money from a different location than you have
Ah, nice.
associated with your Apple card, or
Right.
for example. Or you might want to, or once you build up to $54,000 in your savings account, you might want to take it out, put it in a different place.
Is that the maximum insured amount, 54,000?
No,
I think it's
no.
20. Isn't it 25,000 or something?
It's 250. I think.
250. Oh, wow. Well, that's a goodly amount. I don't think I'm going to be putting that much in there. So, I'll feel safe and secure. Alan, go ahead. Oh, want me to unmute you? No. There you
Unmute.
go.
Okay.
There you go.
I find it interesting that Apple is now contracted with two different banks. The original Apple Cash was the bank that Apple set up, the Green Dot Bank, wherever the heck it's located. And they were collecting a lot of money that would sit in the Apple Cash accounts until you spent it on something, interest-free. And it was a good deal for that bank. Now the way Apple has set up the savings account with Goldman, whenever $1 or whenever any money goes into your Apple Cash account, it is immediately transferred to the savings. That doesn't do much for Green Dot Bank. It's good for Goldman. Goldman's getting your money in an infusion with no advertising, little work. It's just they're paying interest on it, but they're paying interest without having to put out much effort. So I'm wondering what the future of Green Dot Bank is with Apple Cash, or will Goldman take that over?
Sounds like Apple's
Yeah, they
moving
gave
from it.
they gave up a lot of float with this change.
Yeah, the Green Dot Bank.
Oh, many millions of dollars. Yeah.
Yes. Oh, yeah.
Yeah.
So will Green Dot Bank continue in its role, or will it disappear?
It'll be interesting to find out a little bit more about Green Dot. And again, like you said, who's heard of that one? So
Yeah. What's in it for Green Dot now? I see very little.
yeah, Apple's probably just migrating away from it, or slowly. Okay, Mike, go ahead.
Yeah, I think, maybe this is just an assumption on my part, but I think what's happening is that if you don't start your other account, then you're staying with your Apple Cash as it is. And yeah, there's Green Dot Bank right there. But once you do set up the savings account through Goldman Sachs, then you're dealing, you're bypassing that Green Dot Bank then completely, and just dealing specifically or strictly with Goldman Sachs.
Right.
Yeah, I imagine Aaron can probably, fill more in on that.
Yep. Any additional comments about banking? Sounds like a good deal. 4%, 4+%.
Green Dot is the provider of prepaid debit cards. So that's really their function, and that's probably why Apple went to them in the first place. But probably just as an interim.
Yeah.
Apple is slowly getting into the financial industry without becoming directly subjected to the regulations.
Yes, indirectly involved. Yeah. Which is good. Okay. Speaking of little minor hiccups or twists and things like that, I don't know how many people have gone over to Apple's classical music station, which I've been playing around with and using. It's quite nice. I did notice a slight word of warning glitch in it that I fell victim to, that I felt, well, I had to send something off to Apple feedback, as should be. In the classical music, I had a playlist, and I happened to look at my playlist just to see what was there, and I noticed a playlist that I had over in Apple regular music. And it was not displaying a lot, since the app is only designed to, show what's on a phone. So it only showed basically like one or two playlists, but it was a playlist that I had been recently updating, and I had, the day before, I had put it's a monthly set of songs, and so I put all the month songs in there, and suddenly I saw it in the classical. When I was playing classical and displayed the playlist, I saw it there, and I said, oh, and I clicked on it, and it showed me that there was one classical song in it, and I said, oh, I must have inadvertently created the playlist here. And so I thought maybe this was a mistake. I didn't know I had added a song, and I was in the wrong music app creating the playlist when I was creating it for the 30 days of songs. And so I selected to delete it because it only had one song in it. And it gave me some warning message, which I didn't read, which I should have read, that, the classical one, we're going to delete it on all your devices and, for you. And so I deleted that playlist. And lo and behold, what I discovered was the Apple Classical Music Station does include all your playlists from your regular music, but it only shows you the classical songs that are in that playlist. It doesn't show you the whole playlist. So it's kind of a strange situation. So if you've created playlists or you listen to other playlists, I have a bunch. I have 50 or so or more playlists. So if you have other playlists and you're kind of interested in just listening to the classical music that happens to be in a playlist, it's kind of nice to be in the classical thing. I reported it to feedback, and having been a previous computer programmer, I felt pretty much that Apple really should have just provided a link to that playlist and not a dynamic delete of the playlist. It should have had the option to remove the playlist from your classical list or not show them in your classical music thing, because what happened is I ended up when I deleted the playlist, I deleted all 30 songs. And the next thing I discovered that happens to exist in Photos is music does not have a recently deleted folder. So when you delete something from music or a playlist from music, it's gone. I tried seeking a way to get it back and all that, and it would have been very awkward, very hard, or there was no way to restore a playlist that you've deleted. So word of caution about ever deleting a music playlist currently, there's no recently deleted recovery of music or a playlist in it. Or
Make a suggestion.
well, let's go Van first.
Well, wait a minute. I just wanted to say,
Oh.
if you worried about deleting something like a playlist, rather than delete it wholesale and then not be able to get it back, just rename it. And usually there's an easy way to do that, right?
Right.
Just
yeah.
tack on to the end to be deleted, or delete,
Yes.
the word delete or something, and then just leave it there, so at least you'll know what your intentions were if you come back later.
Right.
That's my suggestion.
Yep. It's just I didn't know that the two playlists were the same. I should have realized it. Van,
Maybe Apple will eventually make an undo for that, or some other mechanism.
Hopefully a recently deleted.
This is not to suggest that your idea or your suggestion, your feedback is in in any way incorrect, Roy. But one of the things that was helpful for me, and I had not spent a lot of time with the classical app, but one of the things that was helpful for me was to hear somebody describe it as not so much something separate, but rather a different and more detailed view into Apple Music.
Right.
And so it's tempting to think about them as two separate things. And in fact, it's one thing where all of the classical music happens to be with everything else in Apple Music, but the classical app is teasing out only what it needs to present for those people that are interested in classical music. And
Right.
so I haven't really done what you've done, haven't fallen prey to that or anything, but that was helpful for me to understand that it's not really a separate item so much as it is a view into a
Yes.
larger universe.
Yes. And if you had created several classical music playlists in your regular playlist, it would be nice to see them already in your classical thing displayed.
And I guess what did it do? What did it do, Roy? Did it assume you had a classical playlist because of the music you had in it? You hadn't, there was no way to identify it as a classical music playlist
no.
per se in the old system. So it actually looked at the selections, the pieces you had there, I guess.
Yeah, that's what was so interesting, is it took whatever playlist I had and showed me any classical music pieces that I had in the 30.
Wow.
Which
That's
happened
just
to be
amazing.
which happened to be one. So therefore I assumed it was not the full playlist and deleted it saying there's only one song. That's not my full playlist because I know I just put 30 songs in it.
It's a shame you got bitten by that, but
Yeah.
isn't that remarkable?
But it was a good thing to feedback to Apple. Remember that always, apple.com/feedback. Although they don't have that listed, so they do have the regular music app listed, so you kind of have to sub report the fact of what's happening, that it happened in your classical and not the music, or the music app and not the classic, but not the music app. But Apple still doesn't quite show all their things that are available when you go to the feedback. But I keep feeding them, keep them hungry there, or they keep me. They provide things to make them hungry. So. All right. Yeah, anybody got a new topic? The classical music thing is nice. It does play. And I've got to say one more thing about the classical music. It is really nice when you pick a piece of music that you do like, because when you call it up, it shows you that, here's a piece of music with Beethoven's Ninth or whatever. And, there's 292 versions of it. But it always picks one that's the curated. This is the one we think is the best. So it does give you a point of start. you can find one. It doesn't rank the rest of them, but at least you have one. If you're not even familiar with it, it has one that somebody has felt is the best one to start you listening to, hearing a classical piece that you've never heard before. And you can put composers in and conductors and things like that. So it really is a very nice app if you're into classical music. The jazz fanatics are hoping for a jazz one to come up sometime soon, but which would be nice.
Apple bypassed the opportunity to charge separately for the app.
Yep.
Well, I think it's something that's new, and like all new things, it'll go through some refinements and improvements.
Yep. So everybody else is functioning along quite well. No little glitches or repeating glitches.
Roy, may I just make some quick announcements about upcoming meetings?
Certainly.
Well, first, everyone, I noticed that Kate Howell's is in the house, so
Yes.
welcome, Kate.
Hi, everybody.
Yes. So coming up in May, everyone, will be almost 3 years to the day for David Pogue to come back to the Pi in a remote meeting. And if any of you remember when he first came, it was just a blast. It was so interesting talking about what he was involved in. And he kept going with Q&A with the Pi members for quite some time. So I'm really bullish about this. And I wanted to let everyone know about an exchange I had with him, and we'll see if this goes anywhere or not. You know, he now does videos. He's a media journalist for CBS Sunday Morning. So he's now a real kind of journalist for CBS. And I got the impression when I first reached out to him that he was now looking for paying gigs. All right, so I'm game. I respond to him and I say, well, you know, the Pi could pay you something, or better, the Pi could make a charitable contribution to a charity of your choice, or even better than that, because you know it's much better to give than to receive. You could, in conjunction with speaking to the Pi, make a contribution to our Pi scholarship. You know, it's George Mason. Anyway, I'll follow up this with him and hopefully not get too far out in front of the Pi board about if it ends up costing us money. But anyway, so that's the May meeting will be a really fun one with David Pogue. Coming up in June is a return of Rob Pegoraro. And he's been coming back to speak to the Pi in June, our kind of summer meeting for several years now. And this is always a really fun thing. The one thing is this will be a week early, and it will be another combined meeting with the Patax people at their Ollie facility in Fairfax, the same way we did it last year. So we'll be sending out more information about these meetings coming up. Thanks, Roy.
Okay. Well, Jonathan's covered the announcements. That's the important thing, is that the one with Rob Pegoraro will be 1 week earlier than the normal general meeting. So there won't be a general meeting the following week. It'll be that joint meeting. But again, another live meeting for people that want to come out to Fairfax. And that should be a well-coordinated meeting between the two groups there.
Just to remind, that's where Rob, who actually has been going to conferences for the last couple of years, will bring tables of glam, you know, travel batteries and caps and mugs and
USB thumb drives.
There you go. And I'm speculating that because the conferences have been trying to get people to come more in the last couple of years, that maybe there'll be a ramp up in the utility of the glam. But anyway, this is a big pitch for people to show up in person to claim some of this stuff.
It helps him too, because he accumulates way more, I'm sure, of this stuff than he could ever use personally, because he goes to a lot of tech shows, and you know, they're always trying to push it on you, especially if they know you're a tech journalist. They want their name out there, you know, they hope that you will write good things about their company. But I'm sure, I know from what he said, he gets way more than he can use, so he gives it away to groups like us.
Roy, did you want to talk about the Pi board election? That was
no, you're on the election committee. You might as well.
Well, let's see who's
the rest
here.
of the committee is not here. So
is Gabe here this morning?
Gabe's not here.
No. Diana's
not here. So
okay, so it looks like I'm the election committee representative here today. Our Pi elections for the board members always comes up in June. So we have 4 Pi members who are renewing members. And who is here today that is in that group? Oh, Bruce is. I'm not sure anybody else. But the great news is that Jim Diamond, who is here today, is a new entrant to the Pi board. So wave to everyone, Jim. Yeah, so if the past is prologue, we'll have a presentation by the board candidates at the May meeting, and then maybe run the election in the week after that. So I think the last point I wanted to make is that we have reposed in the groups.io files area bios by all of the Pi board candidates. I'll put a link to that in the chat.
Okay.
Did someone have a question?
Doesn't look like we have any other questions. I think with Kate here, we Jonathan, if we want to, go on to the standard presentation, we can. I mean, seems like a good time to do it because there's no other interrupting topics.
Oh, Diana just entered the meeting.
Yeah.
So why don't we see if she has anything to say about the Pi election coming up, being one of the other election committee people. Diana?
I'm feeling a little behind the curve here because I didn't hear what you were talking about.
Right.
Diana, we were talking about the upcoming Pi board election. So I was telling people about the bios in the files area of groups.io, and welcoming Jim Diamond, who is a new entrant to the Pi board and is here today.
Right.
And do you have anything you want to add about the election coming up?
Well, yes, I do. First of all, I want to thank you for all the work you've done on getting the election pulled together and recruiting an absolutely stellar slate of candidates. I don't know how we could find any better people here, unless, of course, Ann Zabaldo had consented to join us, because I have to keep nagging her about that. But just don't forget to vote, people. Okay, really. And there are more openings on the board than there are candidates, so don't hesitate to just vote for all of them and submit that ballot. Okay, that's really all I can say about it.
And I guess the only pitch I would make to that Diana always does is, once we run the Pi election, if we have vacancies, which I think we still might have one or two, if you would like to join the Pi board, just message one of us, please. Because the only way the groups keeps going is if we continually kind of reinvent. And the blessing that we have is that our Pi members come from so many different backgrounds. So if someone new joins the board, they always add something.
Yes, pretty much related to that is, yes, as Jonathan says, there are probably still some more openings that we have to fulfill. We have a minimum requirement, but I think we meet that. But we still leave that does leave gaps. So if anyone who just has an interest in participating or seeing what it's like to be on the board after the election, and perhaps they're afraid of elections or whatever, let us know. Let us know if you'd like to, join the board. We really do encourage. We like a lot of different, diverse thoughts and comments and directions. There is an executive committee board or committee that is supposed to be meeting to decide the direction that the board takes things. So, we'll be getting that active too. But again, if you have an interest just in seeing what it's like to be on the board, let us know. And after the election, the current board that comes into being will, probably be glad to add you to the board temporary. You can even be temporary. You don't even have to, don't have to be worried about having to go into election until the next time around. So we just need, the board needs the feedback and diversity to move the club forward. And so that's it. Getting off the soapbox. Jonathan, go ahead with turning it over to you for today's general meeting topic.
Oh, terrific.
Mhm.
Yeah, so I am just delighted to have Kate Howells with us today to talk about space exploration and the Planetary Society. In the interest of full disclosure, I've been a Planetary Society member for a long time, and I don't know how to put this nicely, but at the point where Bill Nye came over to kind of take the helm, that didn't dissuade me. uh, anyway, Kate is a public education specialist for the Planetary Society, and she writes on space topics for the Planetary Report and planetary.org. But most interesting, she is based in Guelph, Ontario, and she's involved in the Canadian space community in a variety of ways. So I hope as part of your presentation, Kate, you can talk about that, because I think that would also be very interesting. She also has a book in the Amazon Play Store, in the Amazon bookstore, and enjoys channeling her science interest into creative projects. So, Kate, I will make you a co-host, so you'll be able to share your screen for any content.
Great.
And then we will spotlight you. So if any Pi members cough, that won't take over the screen.
Great. Thank you. Well, thanks for the introduction and for having me. It's always nice to get to talk to people who have similar interests. I get the impression that all of you not only might be interested in space, but also sort of technology, STEM stuff in general. So yeah, I'll give a bit of background about what I do with the Planetary Society and with the Canadian space community. So stepping way back before my time, the Planetary Society was founded in 1980 by Carl Sagan, Lewis Friedman, and Bruce Murray. So Sagan, you may have heard of, probably have heard of. He was a astronomer, a planetary scientist, a science communicator. He did a lot of great work bringing space science in particular into the public realm. Bruce Murray was a planetary scientist as well at NASA, at the Jet Propulsion Laboratory. He did a lot of work on sort of early pioneering planetary science missions. And Lou Friedman was an engineer at JPL as well. So the three of them got together to form an organization because they saw that there was an enormous public interest in space science and space exploration, but that was not being reflected in NASA's budgets. So after the Apollo program, where NASA budgets were through the roof, things started getting brought back down, which needed to happen. But one area where budgets were being slashed in particular was planetary science. So missions to explore worlds beyond Earth, so planets, moons, asteroids, that kind of thing. In particular, the Mars exploration program was being axed. And so they formed this advocacy organization to channel public support or public interest in space into political support for NASA programs. And that's what we still do to this day. We have a strong advocacy program and I'm going to talk towards the end of my brief presentation. I'll talk about missions that we're advocating for right now that we need support for, and that I hope all of you will sign petitions and send letters to Congress and all that. So we do a lot of that. We also do crowdfunding for space technologies. So I'll talk about one of our biggest crowdfunded projects a little bit later on, but we give people an opportunity to directly chip in to making new technologies possible, to make missions, we develop instruments, that kind of thing. And we do a lot of work in searching for asteroids that could pose a threat to Earth. So I'll talk about that a little bit as well. And then we do a lot of public education. That's a big part of my job, is just making sure that the general public knows about what's going on in space science, space exploration, why they should care, why it's exciting and important, and what needs to be done to make more of it happen. So we have, as Jonathan said, we have a magazine called The Planetary Report. We have a website with lots of articles on it. Every week we have at least a couple of new articles come out. We have a weekly podcast called Planetary Radio that I definitely recommend checking out if you're interested in this kind of stuff. We interview people who are at the forefront of space exploration, scientists, engineers, artists, creative types, leaders in government, everybody who's got a role in space exploration comes on the show. So that's kind of the basics of what we do. I also just want to say right now, if anybody has questions, there's the reactions button at the bottom of the screen. I'm going to turn on recognized hand gestures so people can you can raise your hand if you have a question, and I'll try to take them as we go. But if you want, I can also just do a big question period at the end. And I'll talk a bit about Canadian space exploration. So yes, I'm based in Canada. I actually used to live in Washington, DC. I went to George Washington University for their space policy program. But now I'm back in Canada. I had to return to the motherland. I do love it here, even though it's a little chilly sometimes, like today. But I'm very involved in the Canadian space community. It's a much smaller space community than in the US. Our space program is quite modest. We focus on contributing instruments to international collaborative missions, often led by NASA, but occasionally led by the European Space Agency. We have a human exploration program, so we have an astronaut corps. We send astronauts to the International Space Station, and we're going to have an astronaut on the next Artemis mission. So I'm going to talk more about Artemis a little bit later on. We do a lot of space work that's practical for Canada's needs. So we're a very large country geographically with a small population, and although most of our population is right along the southern border where it's more temperate, we do have populations distributed throughout this massive country. So telecommunications, like remote communication, is very important. So we have a lot of our space program goes to making sure that our population, especially remote communities, are connected. And we do a lot of Earth observation work. So monitoring changes in our Arctic lands as climate change moves along, that kind of thing. And we do a lot of that remote sensing work also is applied to the contributions we make to space exploration. So I'm going to talk a little bit later about the OSIRIS-REx mission that is on its way back from an asteroid, and that was one that Canada made a contribution to. So when the spacecraft arrived at the asteroid, it could map it from afar using technology that we've developed to do things like mapping northern areas as they change. Okay, so the plan for this talk is I just want to go through some cool space missions, things that are happening right now, things that have recently happened, things that are coming up, just kind of give an overview of the things that I think are the most exciting. So I will tell you right off the bat that my focus, just based on my experience in my career, is on planetary science and exploration more than like cosmology and that kind of thing. So I know a decent amount about planets and moons and asteroids and the missions that explore them. I don't know anything about black holes, that kind of thing. I wish I did. It's a fascinating topic. Space is huge. I have to focus a little bit. But if you do have questions about more cosmological things, you can try me at the end. But I'll just put out right now that's not my expertise. So what I'm going to focus on is mostly sort of in the planetary science realm. So I will dive in. I'm going to attempt to share my screen. So bear with me for a second. Okay. Let me see. Just a second. I'm not sure. Oh, this is okay. Sorry. I'm
That's
not used
okay.
to Zoom.
In the opening screen of the share screen is where you want to select your content.
Yeah, it's just
And-
not telling me which window is which. So I'm just going to close a bunch of windows so that I don't have that many options. Okay, let me try again. Share screen. Okay, if this will, let's see if this works. Oh, it has to, sorry about this. It's making me grant access through my security systems. Oops, Zoom. Okay. It's going to make me quit and reopen Zoom. So I will be right back. Sorry about that.
That's quite all right. Hey, so while we're waiting, the first question I had with Kate talking about what her interests were and were not is are exoplanets within her ambit. So exoplanets are a little bit of cosmology, but also heavily, planetary sensing, kind of right in the middle. Yeah, so let's bring her back.
Okay. Sorry about that. Once again, let's see if this works. But there we go. Here we go. Okay. So you should see my slide deck. Do you see that?
Yes.
Okay, fantastic. Let me slideshow. Okay. So I am going to, I don't have visuals for every single thing I'm going to talk about, but I have visuals for the ones where there's cool things to see. So in no particular order, just in the order in which I thought of the missions that I was most excited to tell you about. The first one is the DART mission. So this DART stands for Double Asteroid Redirection Test. And this was a groundbreaking mission to see if we could move an asteroid. So as you all know, asteroids occasionally impact the Earth. This is how the dinosaurs' reign on Earth ended. And it could very well be how our reign on Earth ends if we don't do something about it. So a big part of this overall project, which we call planetary defense, which is defending the Earth from asteroid impacts, big part of that is observing, looking for asteroids. The more we know about what's out there, the more we'll be able to defend ourselves if something is heading our way. Luckily, currently, we have found and tracked and characterized hundreds of thousands of asteroids, and none of them are on a collision course with Earth anytime in the next hundreds of years. We seem to be in a very good time in the solar system's development, where earlier there were a lot more small objects flying around, but they collided with things and got absorbed into other planets. Jupiter gobbles a lot of them up with its massive gravity. It's that kind of thing. So the detection and observation and tracking asteroids is a huge part of it. But if we ever do find an asteroid on collision course with Earth, we need to be able to deflect it. So there's a number of different deflection technologies in development, but this one is called the kinetic impactor technique. And basically you fly something directly into the asteroid, bash it, and see if you will nudge it off course. So this is what the DART mission did. It flew a spacecraft into an asteroid and then measured what happened to the asteroid. Specifically, this was an asteroid moonlet. So it's a very small asteroid that's in orbit around a larger asteroid. So they crashed into the smaller one and then measured whether that affected its trajectory around the larger one. So it's sort of a small scale test of a technology that could be scaled up. So you could, if you had a bigger asteroid on course to hit Earth, and you'd found it far enough in advance, like if we've got, say, 10 years before it's going to hit Earth, and you smash it with a spacecraft and it nudges it even just a tiny bit, the way that orbits work in space is that if a tiny little deflection early enough could perturb the orbit enough that it would miss Earth, decades later or whatever. So this impact test happened in September last year, and there's this video that I'm going to show you that shows the perspective of the spacecraft as it approached and crashed into this asteroid. So you can see on the left, there's the bigger host asteroid called Didymos, and then the smaller asteroid moonlet is Dimorphos. So that's what the spacecraft is aiming for. And so, you know, you see it getting closer and closer and closer, and then very quickly it's going to seem to accelerate, but it's really just that it's this is this relatively small object that we're moving towards very, very, very quickly. And so you see it get closer, closer, closer. You can resolve boulders, and then next thing you know, camera goes red. Very dramatic, very exciting. So that was a successful test. They did, they deflected the asteroid moonlet. They changed its orbit around its host asteroid by a much bigger margin than they had hoped for. No, don't worry, they didn't deflect it enough that it's now going to hit Earth. It was never on an impact trajectory, but just a really cool mission. It also created such a huge amount of debris in the impact that asteroid developed a tail like you see a comet have. And normally asteroids don't have tails because comet tails are caused by the fact that comets are largely made out of ice, and the sun's energy turns the ice into gas, and that gas is the tail that you see. But in this case, there was a tail of just dust and debris and rocks as that got kicked up from that impact. So that was really neat. This is the first time we've ever done anything like this. The Chinese Space Agency is working on a similar mission that they're aiming to launch in the next few years to, again, just continue testing what it takes to deflect an asteroid. Planetary defense is one of the things that the Planetary Society is very strong advocates for. And because obviously it's extremely important that we not get all destroyed by an asteroid. But also a big part of what we do is promote international collaboration on this, because it is a planet-wide issue. NASA is a very, very strong leader in space, but it's important that every other country contribute to this as well. And so yeah, we're very happy to see the Chinese Space Agency working on something like this as well. And we advocate for other countries to make investments in, not, even if they don't have the kind of space budget to develop a mission like DART, we still want every country to contribute to observing asteroids, finding them, tracking them, characterizing them, understanding what they're made of and where they're going, whether they're going to hit us. So that's DART. That was one of my favorite ones in recent years. The next one I'm going to talk about is the, oopsie, that's not what I want. Where can I go? Okay, over here. So the Perseverance Mars rover. This was one that landed a couple years ago now. It landed in February 2021. And it's the newest Mars rover. Mars is the best explored planet other than Earth. And the reason for that is that it has the most potential to have had life at some point in its past. Mars now is dry, cold, radiation, like bad radiation environment. It's not hospitable to life. But we know that in the past, it was a more habitable world. It had a thicker atmosphere. It had a magnetic sphere, which protected it from solar radiation. And it had water, abundant water on its surface. And liquid water on the surface is the best criterion we have for the possibility for life to exist on a world, because all life on Earth depends on the presence of liquid water. And unfortunately, liquid water is not super common in space, and particularly not on planetary surfaces. So missions like Perseverance are going and looking for information about past Mars. So it's collecting rock samples from places that we believe used to be watery and wet, and then looking to study those samples to see if the conditions in the past would have been right for life to have possibly existed. There is still the slim chance that life, if it did exist on Mars in the past, could still exist today. So researchers are very keen to look for that as well. The Perseverance rover, which what you're seeing here in this image is the very, very, very cool way that this rover landed on Mars back in 21. It came down in like a pretty normal space capsule. When it was high in the atmosphere, the heat shield of the capsule blew away, and we were left with this system. So we have a jetpack and then lowered down from it on a cord is the rover itself. So the rover is what you see on the bottom, and the jetpack brought it down, basically just placed it on the surface. We have also this great image. This is the actual real image of the rover taken from the jetpack as it was landing. So this was a really exciting feat of engineering to get this SUV-sized rover onto the surface of Mars. It has since 2020, early 21, been roving around collecting samples of Mars rock and caching them in these sample tubes, because this mission is not just a standalone mission, it's part of an overall mission architecture called Mars Sample Return, where we want to bring samples of Martian regolith, which is basically like soil, but technically soil, the definition means that there's microbial life as well involved. And so on Mars, none of that, we call it regolith. So we're trying to bring that stuff back to Earth to study in Earth labs, because although rovers like Perseverance and its predecessor Curiosity, they do have science instruments on board. They can do certain analyses to look for things that are of particular interest to scientists, but it's a very small kit. It's basically, if you imagine, you have if you're a cook, say, and you've got just a little camping stove versus having a full industrial kitchen. That's the difference that we're seeing here. You've got a very small set of instruments on a rover like this, but if you can bring samples back to Earth, you will have not only the entire planet's labs at your disposal, but you also will be able to hold on to samples and continue analyzing them forever into the future. We're still making new discoveries using rocks brought back from the moon by the Apollo astronauts in the 70s. So the fact that as technology advances on Earth, you still have these samples, you can continue to analyze them using new techniques, that's really enormously impactful. But it's very challenging to get samples back from Mars. It's far away. You need to, if you wanted to have something launch off the surface, you'd need to get it all the way to Mars, land it properly, have enough fuel on board. And fuel is one of the heaviest things and therefore the most expensive things to fly through space. So, and then also it is a challenging environment to land on. Technologies like what we have here with Perseverance, with the sky crane, they call it, like the jetpack lowering it down. That's really, really cutting edge technology, still not what would be required to land something that could launch again. So that's a huge campaign. And I'll talk about later. That's one of the things that we advocate for at the Planetary Society is sustained funding necessary to get the next stages of Mars Sample Return funded, launched, and on their way.
Is the Mars helicopter still working?
Yes, so I have a video here of this extremely adorable little helicopter that you see kind of down at the bottom middle. So this is a brand new technology. This spacecraft is called Ingenuity. It flew to Mars on board the Perseverance rover, and then it was put down, and here you can see it flying. So this is the first flying machine that we've ever sent to another world. It is basically just a little drone, and this was just a technology demonstration. So Ingenuity didn't come with particular science objectives. It was really just to see, can we fly something on Mars? And I see a question, go ahead.
I had to find my microphone. I've been wondering about that. How it's a helicopter, but the atmosphere isn't that heavy. How do the blades give it enough lift to make that work? Yeah,
so conveniently, Mars is a small planet and has lower gravity. So it kind of works out, the balance works out well, that yes, it has very thin atmosphere. And so there's not that much to keep you up. If this were an Earth-sized planet with a Mars density atmosphere, it would be much, much, much more difficult, possibly impossible to fly something like this. But because Mars is smaller, the gravity's lower, it's more doable. There's another really cool mission that I have a picture of later that's taking this sort of copter technology to the next level on Saturn's moon Titan. I'm not going to get ahead of myself, but just to say, excited about that one as well. So Ingenuity has done, I don't remember the exact number of flights, but it's far exceeded its goals. They thought, okay, we can get it to fly a couple of times and just see how that works, learn from it, get feedback from the machine, like how it is functioning. they thought that would be a success. It has flown, basically it's kept up with Perseverance this entire time. Perseverance has been roving along, going from sample site to sample site, studying the material there, caching samples, and Ingenuity has been flying along with it the whole entire way. And it's gotten some great images of the Perseverance rover from the air, from the perspective of Ingenuity, that kind of thing. It's really neat. So definitely part of the Mars sample return architecture is to have copters like this involved, so they can pick up caches and bring them back to the rover. This is just much quicker than navigating a rover over, uneven terrain. You can just fly this thing. And they also can serve as scouts. So getting a sense of what's up ahead, so that then that can help the rover chart its path.
Kate, Rich posted in the chat and he said Ingenuity has completed 50 flights.
50 flights.
Wow.
Thank you. Yeah, it's astonishing. And it's, you see this a lot with space missions like this, these robotic missions. They're designed with very conservative goals. Like I think Ingenuity's goal was, I don't remember the exact number, but it was a small handful of flights. And yes, it's done 50. Likewise, you often see rovers that have a life expectancy. Their mission is to operate for 90 days. I think this was the Spirit and Opportunity rovers. They were meant to operate for 90 days. They wound up operating for at least one of them closer to a decade, I think. My memory for numbers is not good. I'll tell you that right off the bat. But the point is, they expect to do something really limited, and they almost always dramatically exceed expectations. So it's pretty exciting to see that happening, and to know that future missions will also have the same thing. Jonathan, I see your hands up.
My question, as you were talking about the particular way the latest rover was lowered, is has every rover landing on Mars used a different landing method? The reason I ask this is one would think that after we'd done this a few times, there would be like a best practices for how to do it. So what's the story?
So it's been different for different rovers because the rovers have been different. So Perseverance landed in the same way that Curiosity did, which was its predecessor, basically the same rover. They have different instruments on them, but they're basically the same. They're in the same box. It's the same kind of vehicle. So both of them landed the same way. Perseverance was different in that when it came down, they had a lot more cameras. They had cameras on the sky crane, cameras on the rover looking up. There was a lot. The documentation was better. You could see the video footage of the landing happening. But yes, basically the same landing technology. Earlier missions with smaller rovers did it differently. Now I'm gonna give away that my memory is not amazing. I don't remember which mission this was, but one of them, basically they lowered it down with parachutes, much as they could. And then it was in this big inflated bubble. Basically, it had all this sort of like a bunch of airbags all around it, and it just bounced down to the surface and bounced and bounced and rolled. And then once it finished rolling, then the sort of bubble layer was shed, and then the rover could roll off. So there's been some really fascinating and ingenious and kind of surprising techniques for landing things on Mars. Because again, part of the problem is that there is this very thin atmosphere, so you don't have a lot of air to slow you down like you would on Earth. Parachutes alone won't do it. But yeah, so there's been some really interesting approaches. I'm going to move along. Oops. Okay. This one, I'm going to mute it. So this is footage from the Parker Solar Probe. So this is, I'm going a little bit outside of my scope of planetary science. This is a solar science mission that is just extremely cool. This happened in December 2021. So the Parker Solar Probe is a NASA mission to study the sun. So it's orbiting the sun, and it has gotten closer to the sun than any previous mission. And this video that I'm going to show you is footage from this probe as it's passing through the sun's corona. So the sun is this big, huge ball of plasma, and its outer layers, the outermost layers, is called the corona. And if you've ever seen a solar eclipse or even photos of a solar eclipse, when the moon completely obscures the sun, you still see these sort of tendrils around the outside. That's the corona. So it's these outer layers of the sun. And the Parker Solar Probe actually flew through that And this is the footage that it got. So you can see the Milky Way passing in the background. You can see those bright points of light are planets. And all of these rays passing by are plasma from, yes, coronal streamers, you can see. So this was just one of the most exciting things. That the probe itself was designed to withstand, obviously, incredible heat. It's just a real feat of engineering that I just think is amazing. And I just think footage like this, it just really captures the imagination. I think it's just spectacular. So the Parker Solar Probe, and by the way, I will also say, if you have if any of these missions that I talked to you about pique your interest, note them down, look them up. The Planetary Society website, planetary.org, we have mission pages for every single one of these. We have lots of images. So I would say go to planetary.org and use our search function to look up any of these that you want to learn more about, because there's a ton more to say about every single one of these than I can possibly say in the time that I have for talking to all of you. So I'm gonna blast through a few more missions. But yeah, there's a lot to discover if you want to dive into any of these. Okay, I'm going to move on to the Juno mission at Jupiter. So this arrived in 2016, so it's been there for quite a while. The plan is to have it operate until 2025, at which point I believe it's going to crash into Jupiter, which is what the Cassini probe, which studied Saturn, did, because you don't want to just leave a dead spacecraft flying around in space with no more propellant to control its trajectory, because some of the moons of Jupiter may be habitable to, microbial life at the very least. Not, we don't expect to find full-grown aliens walking around on them, but there are moons of Jupiter that are icy on their surface, but underneath that ice crust is liquid water, oceans. So they're very prime targets in the search for life beyond Earth. And for that reason, we don't want a spacecraft accidentally crashing into one of them. So we tend to deorbit these things intentionally. But in the meantime, Juno is studying Jupiter. This is one of the many, many gorgeous images it took of the gas planet. You can see on the left here, that big black splotch, that's the shadow of the moon Ganymede, which is Jupiter's largest moon. It's larger than the planet Mercury. It's very fascinating. It likely has subsurface liquid water, oceans, and it's just super fascinating. So Juno has been studying Jupiter since 2016, and now at the tail end of its mission, it's already achieved its main objectives for what it wanted to learn about Jupiter. Now it's moving on to study some of Jupiter's moons. And so one of the first images that it sent back in its new extended mission is this phenomenal infrared image of the moon Io. So Io is the innermost of the big moons of Jupiter. Jupiter's got dozens and dozens of moons. 4 of them are really big and really interesting. Io is the innermost of those, and it is the most volcanically active place in the solar system. Its surface is covered in volcanoes, and you can see all of these bright dots are areas with higher heat. This is an infrared image, so you're seeing more heat. So these are most likely all active volcanoes. And the reason that Io is like this is that it's in between Jupiter, which is enormous, and 3 other big moons. And so as those big moons go around Jupiter and Io goes around Jupiter, it finds itself sometimes tugged this way by a big moon's gravity, sometimes tugged this way by Jupiter's gravity, and all that tugging squeezes it. And if you've ever, had one of those, like a balloon filled with sand and you squeeze it and it gets hot, the same thing is happening inside Io, and it creates an enormous amount of volcanic activity. It's a totally terrifying moon, absolutely fascinating as well. Definitely recommend learning more about Io. And we're going to be learning more about Io thanks to the Juno mission. So that's really neat. Moving right along, the James Webb Space Telescope. Again, slightly outside of the planetary science field that I'm experienced in, but it is a mission that's going to be doing, and it has already been doing planetary science work. It's the most powerful space telescope ever created. It started doing its science mission in July 2022, so just this past July. And it's already just demolishing everybody's expectations. It's doing incredible work. This is an image called a deep field. So the Hubble Space Telescope, which is sort of the predecessor of James Webb, took deep field images as well. Basically, what a deep field is if you looked out into the night sky and you picked a dark spot where there's no stars, and even, you know, with your really powerful ground-based telescopes, you couldn't see any stars in that spot. You find what looks like a patch of nothingness, and you point a telescope like this at that patch, and you collect light for a long period of time. With the Hubble telescope, they would collect light for days on end. With JWST, it was a matter of minutes, maybe hours, I don't remember, but a very short amount of time compared. Basically, it's so sensitive that you give it a little bit of time to collect light from an apparently dark spot, and this is what it sees. Everything here is a galaxy. Everything, even the little dots that look like they might be background stars, those are galaxies. This is an amazing demonstration of how much stuff is in the universe. Even when we look at an area that looks like it's empty, there are thousands of galaxies. And the farthest galaxies in this image are billions of light years away, which means that their light is coming to us from a source that emitted that light billions of years ago. And we're looking at objects as they existed at the very, very beginning of the universe. Again, this is outside of my field of expertise, so I can't get too into the nitty-gritty of it. But again, if this piques your interest, look it up. James Webb Space Telescope, Deep Field. We've got information about it on the Planetary Society website. It's just an astonishing marvel of human ingenuity that we have the ability to create something that can look back in time to the beginning of the universe, and tell us so much about what's going on at that stage in the universe's development and ever since. And this space telescope, again, it's just getting started, and it's already exceeding expectations. This is another image from JWST. This is Neptune. Let me quickly double check this. Yes. This is Neptune. Uranus and Neptune, they're both outer planets. They're both ice giants, and we don't know a lot about them. They're both kind of mysterious, so I mix them up sometimes. But this is Neptune, and you can see its system of rings. We have not seen Neptune's rings very much because they're very, very faint. But this is an image looking in the near infrared. So it's able to capture them. And then this very, very bright object is Neptune's moon Triton, which is, it's shining like this because it's an extremely reflective object. It's got an icy surface, reflects a lot of light. And so you see it very bright in this image. So this is just one of the first planetary images taken by JWST. So a lot of what it's doing is looking at distant galaxies and nebulae. It's also looking at objects within our solar system. I see a question from Anne.
Thank you. This is so interesting. In the previous slide, what were those very bright spots? Those
These ones.
center? Yeah. What are those?
They're all galaxies. So some of them are going to be brighter because they're nearer. And again, I'm not an expert on this image. I believe though that the brighter ones, like these ones with the sort of classic star shape, I'm not sure if you can see my cursor, but the ones with the kind of classic six lines emanating from them, those are, I believe, just nearer. And then these really bright ones in the center are also just closer by. Another interesting thing that's happening here is that on either side of the sort of bright white ones in the center, you see galaxies that appear to be sort of bent, it's like this sort of bent shape. And that's because of something called gravitational lensing. So those are galaxies that are farther back than the bright whitish ones at the center. And so their light is to reach us has to go past these very large galaxies, and the gravity of those galaxies actually pulls on the light and makes it appear to bend. It's this really hard to wrap your head around phenomenon that I think Einstein predicted and now is being confirmed. It's physics at its finest and most mind-blowing. Yeah, absolutely fascinating. Does that answer your question overall, Anne?
Oh, it does. It really is fascinating. You know, when you see all this stuff, we can't possibly be alone in the universe, really.
Oh,
We can't.
I completely agree. Yeah, there's just the number of, because another thing too, it is that we are, I don't have slides on this in particular, but there's a field of research studying what's called exoplanets. So exoplanets are planets that orbit around other stars. And once we got the technology to be able to actually detect exoplanets, we started finding them everywhere. So basically, we now think that just about every star out there has multiple planets around it, just like our sun does. And that means that, you know, we know that there are billions and billions and billions of stars in the universe. The number of planets is even larger. And then we also now know from our own solar system that most planets have multiple moons, and that those moons also could be places where life could exist. So now you're just exponentially increasing the number of places that we could potentially, that life could exist, and just the numbers involved. The idea that Earth is the only place with life, let alone intelligent life, I mean, that it just becomes absurdly unrealistic that we would be that special when there's trillions, quadrillions of potential worlds out there that could have life. So yeah, it's a really, the more you learn, the more your mind has to expand to encompass all the real possibilities that are out there. Jonathan, I see your hand.
Yeah, may I? You know, the interesting thing about this is, for a long time, we heard about, quote, Goldilocks zone.
Yeah.
But now with the appreciation that a moon of Jupiter might have a subsurface saltwater ocean that almost certainly has some kind of life when you consider how life started on Earth. So doesn't that blow up the Goldilocks zone thing?
Yeah, absolutely. The Goldilocks zone is this idea that at a certain distance from a star, based on the star's size and brightness and how much heat it's putting out, that there's a certain distance where it's not too hot, not too cold. And so, of course, we call that the Goldilocks zone because space scientists are adorable nerds. And so we find cute names for things. And so that basically is that if it's not too hot, not too cold for liquid water to exist on the surface of the planet. So that is still a factor. But yes, now we know that moons, I'm actually going to skip a few slides ahead to talk about, so this is Europa. This is one of Jupiter's other large moons. And this is one of the ones where you see there's this icy crust, and that all of these cracks give away that there's something liquid underneath. We're seeing basically the similar kind of thing as plate tectonics that we have on Earth. So on Earth, we have a solid rock crust floating on a liquid rock magma layer. And that's why we have the movement of continents, and we have mountains being created, and we have earthquakes and all of that. We're seeing the same thing on a lot of icy moons of the solar system, where instead of rock on liquid rock, it's ice on liquid ice, aka water. We also have been able to calculate from remote observations, the spacecraft flying past Europa and measuring its magnetic field, that kind of thing. We can gauge what is underneath that. Europa, even though it's a small moon, it's I mean, gosh, I don't remember the exact size, but I think it's I think smaller than Earth's moon. Anyways, it's moon sized. It's small. It still has more than twice as much liquid water in its subsurface oceans than the entire Earth does. So there's an enormous amount of water here, and we also know that it's salty, and that means that water is in contact with a rocky seabed underneath, because that's where salt comes from in our oceans as well. It comes from the ground underneath at the bottom of the ocean. And so, like Jonathan said, one of the best bets of where life on Earth originated is on the seabed, where there are hydrothermal vents that bring energy from the heat of the core of the Earth. It comes out as energy that can drive metabolic processes that can spark life. We don't know for sure that this is where life originated on Earth, but that's one of the best bets. So we had these same criteria on Europa and on several other icy moons of the outer solar system. So moons of Jupiter, Saturn, Uranus, and even Neptune. So we have liquid water. We have an energy source coming from the rocky core. We have protection from radiation. So the thick ice crust does a phenomenal job of protecting the water underneath from the intense radiation that not only the sun emits, but that Jupiter itself emits. If you were on the surface of Europa, you would not be happy. You would be killed by radiation. But underneath that 30-kilometer thick ice crust, you have a much better chance. So Europa is one of the prime targets for planetary exploration because it has this potential to host life. Another real prime target is Enceladus, which is a moon of Saturn. Similar kind of thing going on. We've got an icy crust, subsurface ocean, salty water, energy coming in from the seabed. But the difference is that whereas Europa has a couple little fissures where maybe there's some water spewing out through the ice out into space, Enceladus has massive geysers that are shooting water high into space. So there's a mission on its way to, or in development, that is aiming to arrive at Europa in 2030 called Europa Clipper. And this mission is designed to basically find those plumes of water that are shooting through the ice and fly through them, capture some of that water and analyze it and see if there's building blocks for life, like things like amino acids, or if there is even any sign of active life. A mission to Enceladus is not, that we don't have anything officially in the works right now, but that's something that is definitely in the long-term plans for the planetary science community. We also have a mission called JUICE that was that's led by the European Space Agency that actually just launched last week, and it's going to arrive at the Jupiter system in 2031. So it takes a long time to get somewhere far away in space. But JUICE it stands for the Jupiter Icy Moons Explorer. It's going to study Europa, which you see here, Ganymede, which is the one that's bigger than the planet Mercury and has similarly this icy crust with probably water underneath, and Callisto, which also has these same kind of conditions. And so there's a lot more interest building in studying these moons of these outer worlds because yes, they've blown this Goldilocks zone idea out of the water of like where we would need to look for life. So okay, I'm going to move on to Dragonfly. This is one of my favorite upcoming missions. It's heading to Titan, which is a moon of Saturn. It is also roughly the size of the planet Mercury. This is the big moon. Very cool. So on the left, what you see is what Titan would look like if you were just looking at it with your eyes. It has an incredibly thick, dense atmosphere. Now on the right, you see what you could see if you had bionic eyes that could peer through the atmosphere. I think this is a radar image. So what you can see is the surface, and there are these dark features are planes of material that is kind of like coffee grounds colored. And then I don't know if you can see it in this image, but near the poles, there are also, I think, oh no, I didn't get an image of that. Anyways, there are lakes and seas and rivers, but they're not made of liquid water. They're made of liquid methane mostly. So methane on Earth is a natural gas. We're very familiar with it as the thing that, environmentalists, like vegans, for example, tout that cattle fart and burp out so much methane that it's contributing enormously to climate change. Like this is a gas on Earth, and it is one of the big greenhouse gases that we have to worry about. And most of Titan's thick atmosphere is made of methane. But it's so cold out here in orbit around Saturn that methane takes a liquid form on the surface. And so it creates a topography on the surface of Titan, a lot like what you see on Earth. The only other place in the solar system where we have things like lakes and rivers and seas, and then you have, the erosion of the landscape. They have a bizarro water cycle where it's the methane cycle where it evaporates from the surface it forms clouds that move across like through the sky and rains down. It erodes mountainsides as it collects into rivers and then collects into lakes. You have that whole water cycle, but just this extremely cold version. And it's just a fascinating little moon, or big moon rather. It also may have conditions that could be hospitable to life, but a more different life form, not something water-based, but it's possible that the organic chemistry or the chemistry for life could be translated to a different set of things. So, using different building blocks, using a different solvent than water, metabolizing differently, et cetera, but just with these different the chemicals that are available on Titan. And so this mission called Dragonfly, here you see, this is my colleague Amber at a very recent conference, where what you're seeing to her left is actually a augmented reality projection. So that's not right physically there in the room, but this is what the Dragonfly spacecraft would look like. And so it's much, much bigger than the Ingenuity copter, but this is also a copter. So this would be a flying spacecraft. And because Titan is small, it's much smaller than Mars, and it has a very thick atmosphere, it's very easy to fly. This is a place where if you strapped big enough wings to your arms, if you were somehow on Titan, you could get airborne just by flapping, human-sized wings, which is, as we know, not something you can do on Earth, but there you could fly so much more easily. So we have this very large drone spacecraft that is going to be arriving. It's meant to arrive in 2034. It hasn't launched yet. It's still in development. But this is going to be a real exciting mission to see, just something flying around in this bizarro world where it has, it can be flying over coastlines and networks of rivers and that kind of thing, and studying this very alien moon. So that's something I'm looking forward to. It is unfortunate though, you have to wait, more than 10 years to see this thing actually arrive. You have the space game is a patient person's game. Another set of missions that's really interesting is are missions to Venus that are coming up. So this is an image of the surface of Venus. Venus also has a very dense atmosphere, so you wouldn't see this if you were just floating in space looking at Venus, but this is what the surface looks like. This is a composite created from data from several different past missions that have orbited Venus. And there are two missions that are in development right now to arrive at Venus in the late 2020s, early 2030s. And basically, we want to study this planet more because it is very similar to Earth, but has had a very different history. So Venus, like Mars, we think used to be watery and had a pleasant climate, very Earth-like temperatures with water oceans all over its surface. And it experienced a runaway greenhouse effect. So same vein as what we're having with climate change on Earth, where more greenhouse gases enter the atmosphere, that traps heat from the sun, that increases the temperature, that creates more greenhouse gases, and it just snowballs. And now Venus is this place with an extremely thick atmosphere that traps an enormous amount of heat. The heat on the surface of Venus, it's hot enough to melt lead. You would not want to be there. We've landed a few spacecraft there, but they have not lasted very long because the conditions are so intense. The atmospheric pressure is also equivalent to being about a mile underwater. So if you went a mile down in the ocean, you've seen, I'm sure, the types of submarines that have to be developed to do deep sea exploration. They have to be super, super thick because the pressure is so crushing. So likewise, if you want to land something on the surface of Venus, it needs to be extremely durable because there's so much atmospheric pressure. I read that it's about 1,300 pounds per square inch. So it's the equivalent of if you can imagine the weight of an entire small car resting on your thumbnail. That's about that much pressure on your entire body is what you'd be experiencing if you were on the surface of Venus. And so obviously you would be crushed, if you were just there, just in your human body. So it's a very intense, inhospitable environment, but that used to be very pleasant. So there's a lot to learn about the history there, what happened, and potentially to apply to our understanding of our own planet, but also just to understand this world itself. There's also there are a lot of mysteries still to be solved about Venus. There's recent evidence that there might still be volcanic activity taking place there. We don't know for sure. So more missions to study it would be worthwhile. So NASA is sending a probe there that's arriving in 2029 called Da Vinci, and the European Space Agency is launching a mission called Envision, which is meant to arrive. Oh no, sorry, these are launching in 2029, and this Envision is launching in 2031. And so it doesn't take as long to get to Venus. So it's not like a decade-long journey like it is to get out to Jupiter or Saturn. Oh yeah, so another mission that we want to get off the ground that the Planetary Society is very actively advocating for right now is called Veritas. This is a NASA mission that was in development and then suddenly had its budget cut because of cost overruns on other missions and just generally tightening of the budget. But we're advocating for this mission because it would be specifically looking to map the surface of Venus. So this image that you see here, most of where this data comes from is the Magellan spacecraft, which orbited Venus in the late 90s. We haven't had an orbiter from NASA at least since then. So it's been decades with nothing. And Magellan mapped the surface, but at very low resolution. So the Veritas spacecraft, what you see on the right is the resolution that it would achieve of mapping the surface versus what we have from Magellan. So as you can see, you can't glean a lot from the Magellan image, but Veritas, you could see this looks like a volcano, for example. The other two missions that I mentioned, Da Vinci and Envision, that are already in the works and will be getting to Venus in the early 2030s, those are to study its atmosphere primarily, which is very fascinating, but Veritas would study the surface, so it would teach us an enormous amount about the planet that we don't know right now. Because like I said, Magellan is the best data that we have about the surface. And as you can see, it's nothing compared to what we could do with something like Veritas. So that's something the Planetary Society is very keenly advocating for. Like right now, we have petitions you can send to Congress to speak up for this mission. We're working really hard on trying to get Congress to understand why it's important to keep it. Okay, moving on. Oh, that's it. Those are all my slides anyways. There's a couple other things I wanted to talk about. So the Artemis program is to send, I don't have pictures of this because it hasn't happened yet, but this is a mission architecture, which includes several individual missions, which is to get humans back to the surface of the moon. You've probably heard about it. Anything that has to do with astronauts gets a lot more public attention. The media love it. Compared to robotic missions, still get public attention, but not as much. So Artemis 1 flew already. This was just to prove that the rocket and the capsule could do what they needed to do to get around the moon and come back. Artemis 2 is aiming to launch next year. That will carry astronauts. They just recently announced the 4-person crew that will go. It's 3 Americans and 1 Canadian. Very proud. And they're going to go on this mission like we did in the Apollo program. Before you land people on the moon, you got to make sure that the system works. So we're going to have Artemis 2, which will send people in a capsule to orbit the moon and then come back to Earth. And then Artemis 3, they're targeting 2025. I would bet that that's going to slip by a few years, but that would be to actually land people on the moon again. So that's a very exciting mission. Human spaceflight is always complicated because it's just so much more expensive than robotic missions, because you need to keep all these people alive. You need to have protection from heat, from radiation. You need to give them food and water. You need to have communication systems in place. You need just space for a person to move around and not go crazy. You can't just have them in a capsule for like a month or whatever. And so all of that, there's so many factors that make it so much more expensive, so much more difficult. So it's a slower moving program than robotic exploration. There's a lot of people who think that it's not worth the money because it's just much more expensive, orders of magnitude more expensive. But the advantage is that you do have then humans there. So like we saw with the Apollo program, human geologists were sent to the moon to identify rocks of scientific interest, collect those rocks and bring them back to Earth. This is something that the Artemis program could do as well. It's just you can't send a rover to do a human geologist's job in the same way that a human can do it. Even just walking around identifying rocks as opposed to programming a rover to, move here 2 inches, move here 2 inches, try to pick this thing up. So hopefully there's a lot of scientific benefit to doing this. But it's also just getting the human space exploration program sort of back on track after it sort of has lulled in low Earth orbit and the International Space Station for several decades. I'll take, is that Jonathan? Yeah, I'll take your question.
Oh, what I was wondering is the recent SpaceX launch and blow up is somehow connected to this.
Yes.
So
Yes,
how is the SpaceX effort going to work with Artemis?
So SpaceX is planning to contribute their Starship spaceship. So it's spaceship as opposed to spacecraft basically means that it's something that humans can go into. We can call it a capsule or a vehicle as well. Anyways, the Starship vehicle, which is what blew up 2 days ago, the intention is for that to be part of the system that lands humans in the Artemis 3 mission. So people would go down to the lunar surface and then launch back off it again in Starship. So that's something that SpaceX is contributing. The test launch 2 days ago, yes, it ended in an explosion, but no, it wasn't a failure. This was their first time launching this very large vehicle on top of one of the largest rockets in existence right now. And so those combined created the biggest combined launch vehicle ever. And so just getting it off the ground and past the launch tower was a success. Yes, it lost control and they had to just set it to self-destruct because it was out of control. But it did still achieve their primary goal. So there's still more testing to do. But these things are difficult. We're doing new things with new, very powerful technologies that we don't fully understand yet. And that's why I think the target date of having people land on the moon in 2025 is unrealistic. I think it's going to be a little bit longer because these things take time. And we have to make sure it's safe. It's very important that you not explode astronauts. It has happened before, but it's very, very, very bad. And obviously we want to avoid it at all costs. So it's better to delay than to go prematurely and have it end in disaster. Not only because loss of life is tragic, but also because the effect on public opinion on space flight, which is ultimately very important because public opinion dictates public funding, like what's politically viable to fund. So if everybody says, you know what, we saw all those astronauts blow up, we don't want you to invest in space anymore, I'm not going to vote for you if you invest in space, the members of Congress who set these budgets will respond to that. So it's very important to be safe, not only for the sake of the lives of the astronauts and their families and all that, but also for the sustainability of the space program. We want to maintain public trust. So that's very important. Mike, go ahead.
Yes, thank you. A wonderful presentation. I've heard that the Starship rocket has something like 36 or 39 engines on it, which kind of, I understand, follows the Russian version of producing rockets, whereas our rockets have maybe 5 engines on them. To me, the greater complexity with all of those engines may lead towards the calamity that they had with that. Do you have any understanding on why they went the way they did? The other part too is that I'm gonna, I can't have it shown. I have a book called Traveler's Guide to the Stars, and it's written by a physicist with NASA, Les Johnson, and he's writing about the ways we're going to have to change things in order to have, if we ever want to, interstellar travel, simply because of the vast distances that we have, how
Mm-hmm.
difficult it would be. And you know, it's just an interesting book. I'd like to. I put a link to it in the chat with at Amazon.
Yeah, I've heard of Les Johnson. I think we've had him on the Planetary Radio podcast before. And he's involved in he's involved in solar sailing missions, which is, I'll actually go back a few slides. I skipped this one. This is a picture of the Planetary Society's crowd-funded solar sailing spacecraft called LightSail 2, which we flew. It was in orbit around Earth from, let me see, where did I put it? Oh yeah, from June 2019 to November 2022. So this is the technology that Les Johnson has been working on as well, and it's very very intriguing for the possibility of interstellar travel, because yes, stars are very, very far apart, and we're very limited in our ability to move quickly, and especially if you require propellant to push you forward through space, to accelerate you. Like once you're in space, nothing's slowing you down, so you can go, you know, you just need to get an initial boost. But even with that, even with those kind of advantageous conditions, you still can't really get fast enough with traditional propellant to make it to another star in any reasonable amount of time. Solar sails take advantage of the fact that sunlight, although light itself doesn't have any mass, it does have momentum, and that momentum can be transferred to a spacecraft using what's called a solar sail. And so this is a picture, it's kind of like a bit fish-eyed, but this is from a spacecraft that the Planetary Society built, and we did so with the support. It was entirely paid for by individual contributions from our members and from donors over many years. And it basically went into Earth orbit, and it was a spacecraft about the size of a bread box, or like a loaf of bread. And it put out these booms and deployed this sail about the size of a boxing ring, we say, that's made of this really, really thin, very reflective material called mylar. And sunlight bounces off the mylar, and that bounce provides a push. And the great thing is, because nothing's slowing you down in space, especially, you know, going around Earth orbit is a little different, but if you're going out, you know, on your way to another star, there's nothing slowing you down, but you're getting a constant source of acceleration from sunlight. So it's pushing you faster and faster all the time, nothing's slowing you down. So you could potentially reach these phenomenal speeds that would be required to get a spacecraft to another star system. Now, is that spacecraft going to be big enough to have people in it? Probably not. And then also, how would you get them home? Bit of an issue there, but we could potentially send robotic missions to other star systems using this kind of technology. And I was very proud to be part of an organization that was advancing this technology. So LightSail 2, which you see here above Earth, it was the first time that a solar sailing mission had proven that it can work specifically for this type of what's called a CubeSat, this small satellite. But since that mission success, other missions from NASA and from private companies, including 2 missions that Les Johnson worked on at NASA. One of them is called Solar Cruiser, and the other one is called NEA Scout, Near Earth Asteroid Scout. So it's using solar sails to propel a spacecraft that's looking for asteroids. These have drawn on lessons learned from the LightSail mission. So that's just a super cool way that we're helping to advance space exploration. So just a little Planetary Society plug for you there. I see David has a hand raised.
Yes, I belong to a club here in Washington, and we have a science group. And for the past 3 months, they've had scientists who are involved in the Webb telescope showing images and talking about it. And this coming month, a woman, Heidi Hamill,
Yes.
is one of 6 scientists for the Webb telescope, and she's going to be talking to the group and presenting what they hope we can learn from it. There's one thing that came up back when we had a number of scientists in successive months talking about the Hubble telescope, and that was the ability to verify the existence of parallel universes. And I keep pursuing this with every new person who comes to talk to us. And I seem to get a confirmation that yes, there are parallel universes for Earth. And now that the Webb telescope is going to deal with time as it goes back in time, I don't know if that will either provide more information about this. And I keep looking for sources of information about parallel universes and the possibility and what it means. Any ideas?
I wish I could say yes, but no, that is so above my head. I'm fascinated by it. But unfortunately, my realm of knowledge is really about, these physical things in space, and this more theoretical stuff. As much as I love it, I really don't know a lot about it. But yeah, fascinating. I definitely would say, yeah, keep looking into it, and I will as well, because it's just so cool. But I really don't know. I didn't know that Hubble had anything to do with that either. I would love to know more about that. I will also say Heidi Hamill, who you're going to hear from, she's fantastic. She's the vice president of the board of directors of the Planetary Society. She's been with us for a long time. She's a planetary scientist using the James Webb Space Telescope to study planets and moons within our solar system, among other things. But she's fascinating. She's a great speaker. You're going to learn a lot from her presentations. That I'm glad to hear that you're going to be hearing from her.
Yeah, well, it's a good group, and they seem to get in very good speakers and to do presentations for us. But
That's
thank
great.
you very much. I'm really fascinated with your discussion today.
Thanks, David. And yeah, I hope you can follow up more. I mean, yeah, like I said, planetary.org has so many more educational resources on everything I've talked about. So I definitely encourage you to explore that. Jonathan.
Okay. Oh, one thing, Kate, before you leave, if you could put in the chat any links that you want people to be able to have,
yes,
please do that. I had just a question about the solar sail and Interstellar, and I'm trying to figure out how that would work. So let's assume that a solar sail was accelerated to a very high speed and it left the solar system. There would be no more sun then, right?
Yeah. So, basically it would get all of its acceleration while it was still in the solar system. So it would have a long time to continue getting sped up. Like it takes even the fastest thing that we've sent, which was the New Horizons spacecraft, which went to Pluto. Even that took, I think, 10 or 12 years to get to Pluto. So you're going to have years and years of picking up constant acceleration while you're still within the influence of the sun. And yes, once you get far enough away from the sun, that acceleration will decrease, but you're not decelerating because you're in the vacuum of space, nothing's slowing you down, there's no friction. So you would still be able to get to another star much faster, exponentially faster than you could if all you were using was rocket fuel as propellant, or as your propellant. So yeah, does that make sense?
Sure. It's so cool to think about.
Yeah, it's cool. It's very futuristic. It's really neat. And it's just great that these are, they're futuristic sort of sci-fi ideas almost, but they are in the realm of the possible. I'm going to put, as you requested, I'm going to put a link in the chat here. This is our Advocacy Action Center. So if you go to this link, you'll see under current actions several petitions that you can sign. Basically, you plug in, I think, your address, and it tells you who your representatives in Congress are, and it gives you a form letter to say, I support this or that. So there's the Veritas mission to Venus that I talked about that needs support. There's another mission called Neo Surveyor that we are advocating for that would be a space telescope, so a spacecraft in orbit around Earth that looks out to areas of space that it's hard to see from Earth to look for asteroids, potentially hazardous asteroids. So that's something that's very important that we're advocating for. There's a petition to keep adequate funding and a responsible timeline for Mars sample return. So bringing the samples back from Mars that Perseverance has been caching. We have a petition generally for NASA's budget to keep it strong. And we have another one for maintaining funding for the Artemis programs to get humans to the moon. So those are things, if you want to take any action, it's really quick, just a few clicks and you can make a contribution. I would also say once you're on planetary.org, explore our resources. Under the top menu, there's a tab called Explore Space, where you can look at, we got under space topics, there's planets and other worlds. So if any of the planets or moons I've talked about today are interesting to you, you can learn about them under that menu. There's also a whole section on missions. So you can learn about individual missions. We've got resources on what you can see in the night sky right now, about meteor showers. There's a meteor shower peaking tonight, for example, so you can learn about that. We've got images, we've got the radio, the podcast, all kinds of things, and you can read the digital version of our magazine online as well. I definitely encourage you to become members if you're interested in planetary science, in space in general. We are the largest and most influential nonprofit organization dedicated to advancing space exploration. The other kind of space advocacy groups are all run by industry. So it's companies that want to get their instrument built, or like they want to be the one to build the rocket or whatever. So they advocate so that they can get, contracts, but we're the only one that really bring people together to fight for planetary science. So if this is something you're interested in, you can join. It's about $4 a month at the lowest level for membership, and you get all kinds of opportunities to connect with other people interested in space as well. We have a member community online that we just launched this year, where you can talk to other members and take online courses and attend virtual events and learn things like what I just presented, but even better from people with even more expertise. You get exclusive access to those kinds of things to learn more, and opportunities to take action to help support space exploration. So I definitely encourage membership in the Planetary Society. I've been working there for almost a decade now, and I'm just a huge believer in what we do. It's just a really phenomenal organization, and I'm very fortunate to be part of it. And I would, encourage you to join as well. So I think that's pretty much it for me. Are there any other questions?
I wondered if you could talk a little bit about the low Earth orbit problem with all of the junk and what can be done to ameliorate that.
Yeah, so this is like a tiny little bit outside of my area of expertise, but basically the issue is that there's limited space in the space around Earth, and we have a congestion problem. There are just, I don't know the number, but thousands, maybe tens of thousands of satellites in orbit around Earth. We've got, communication satellites, your GPS, your internet satellites. We've got military satellites. We've got like private satellites. We've got governments. There's ancient spacecraft that have been just floating in orbit, not operational anymore for decades. There's just a lot going on, and every once in a while there's a collision, and when there's a collision, that creates debris. So now there's even more stuff in orbit, and it's this real problem, because there isn't a clear path to get rid of this stuff. Part of that is just a policy issue. That, for example, if France launches a communications satellite into low Earth orbit, and that satellite runs out of gas and can't be controlled anymore and is just floating around, legally only France is allowed to touch that. They could conceivably send a spacecraft up to grab it and bring it back down to Earth. What I just described sounds simple. It's actually incredibly complicated and very expensive, and we don't have that technology yet. But part of the issue too is that legally, NASA would not be allowed to launch a mission to go get another country's satellite. So there's all these kind of issues with the international element of this common space around Earth. So there's policy obstacles, there's technological obstacles, because it's very expensive to launch anything into space. And so if all you're doing is going to pull a satellite down, that's an extremely expensive mission. And so it needs, who's going to pay for that? And how are they going to pay for it? And how could that be justified and all this? So there's a lot of obstacles in our way. There are groups that are dedicated to dealing with this issue. One of them is called the Secure World Foundation. They are very involved in tackling this problem, dealing with this buildup of congestion. And there's also the issue that the more satellites there are in space, the harder it is for ground-based observatories to look out into space to study other stars and study galaxies and that kind of thing. There's a particular controversy right now around the Starlink constellation, which is tens of thousands of small satellites being launched to provide remote internet for the whole world. You know, great to be able to live in a really remote place and get high-speed internet, which we can't currently do for a lot of places. That's fantastic, but it does come at this cost. Now there's all these satellites streaking across the sky, many, many more than there used to be. And so if you are a ground-based observatory trying to study things in distant space, you have all of these streaks coming across your field of view now, and that interferes with your ability to do science. So there's a lot of complications there. It's a complicated issue. It's a nuanced issue. It's an international issue. There's money, there's technology, there's policy. All that comes into play, and there isn't a clear path forward, but it is something that is pressing and that people are working on in like international space policy circles. So I wish I could say, here's what we're going to do to fix it. But the reality is that it's just deeply complicated problem.
I think, wasn't there something that was like a demo that was launched recently as a method of addressing the very small particles? There was something, I thought.
I don't know. Again, this is like slightly outside of my field that I focus on, but so I just probably didn't hear about it. But yeah, I mean, I wouldn't be surprised because it is a pressing issue. And so there's, you know, if things like, yes, little bits of debris as opposed to an entire satellite, like, yeah, if like a Russian military satellite goes out of operation, we are definitely not grabbing that and pulling it down. Huge geopolitical reasons not to do that. But if there's just a bunch of debris left over from an impact between two satellites, you know, a decade ago, and we could go scoop that up, that's a lot easier from like a geopolitical perspective, potentially also easier from a technology perspective. But yeah, I just don't know a lot about that.
Pi members, any last questions for Kate? Kate, this has been fabulous, just fabulous. Thanks so much.
Thank you. I mean, it's my pleasure. I'm always happy to talk about this stuff. I genuinely do just think all of this is so cool and interesting, and I love sharing that with people. And yeah, I hope that I've sparked some interest for those of you who didn't know about this stuff already, and maybe deepened it for those of you who did. Yeah, and I mean, I can't say again enough how much you should join the Planetary Society if you like this stuff. It really is this just great global community of people who share a passion and work together to make more exploration happen. It's a very good community. So yes, one last plug for that.
May I close down your screen share?
Oh yeah, absolutely.
Yeah, so what do I want to show?
Yes, thank you, Kate. That was an outstanding, very informative, very fascinating
Thank you.
presentation.
Thank you very much.
Oh,
so Kate, can you see our handsome Pi mug?
no, we're seeing
I see a
space junk. No,
bunch of junk, yeah.
club junk.
Okay,
That's our space junk.
Our space junk. Let's try. Oh, there it is. Sorry about that. Let me try that again.
Oh, yes, I see that.
So in appreciation for your presentation today, we will be happy to snail mail you one of our handsome Pi mugs.
That's wonderful. Thank you.
And we only ask that when this comes into your hand, you send back a selfie of you with the Pi mug, because we kind of keep a folder of those.
Absolutely. Yeah, that's no problem. Thank you. I look forward to receiving it. I don't know if you have my address already, but if not, email me and I'll get it to you. But that's great. Thank you.
Sounds good. Roy, yeah, anything else for our guest?
I don't think so. I accept appreciations of very great presentation, very informative. So
thank you so much. And yeah, thank you all for your attention and for your questions and everything. And yeah, and thanks for inviting me to be here. So I will pop off and go get some lunch.
Okay.
But enjoy the rest of your Saturday, and thanks again.
Thank you again.
Okay, take care, Kate. Bye-bye.
You too. Bye-bye.
Yes, that first picture was some of our pie junk that's going to be appearing at our next meetings. Pie in the sky meeting. Stuff.
So in the time remaining, go ahead, Roy. I'll generate the door prize winner for today's meeting.
Okay, I was hoping you'd have that, but Jonathan's going to prepare our drawing winner for this meeting. So then we can go out and enjoy the day before the rains hit. If you have any last minute, unless rain has already come, I don't know. I'm down in the secluded cellar here with no windows. So, but time to get those last minute tasks done before we get to nice deluge of rain from what our predictions are. Just a reminder to go to the groups IO and let us know if you're going to come to next week's meeting. We'll have some snacks and some coffee there or whatever, and so let us know, and then we know what to bring and have on hand.
Oh, sorry, let me try this one more time. Okay. 5, Joe Pinder is our winner today.
Okay.
Joe, are you still here?
Yes, Joe.
IR.
Joe, would you like a $25 Apple gift card or an Apple AirTag?
I think the gift card. I'm in the thank you. I'm in the market for a new Mac, so probably that's best.
Roy, do you have Joe's email address?
Oh, it's probably best to send me the one that he wants me to use.
I will.
To have the card.
Could you do that, Joe?
I will. Yeah. Thanks.
Because I know sometimes I have several email addresses to use.
Yeah, I still need to help work that out. Jonathan's helped a bunch, but anyway, I'll send it to you outside of the group.
Okay.
Thank you.
All right. Well, I think with that, we can wrap up this Saturday's meeting and hopefully see a few live people next week or Zoom people. And then the clubhouse will be the next first Saturday in June. So we'll see people at the next clubhouse.
Yes, thanks for everybody watching on YouTube. And we'll send around the chat for the meeting with the links that Aaron included and the planetary links that Kate included. So thanks everyone for coming today.
Okay.
Bye, everybody.
Aye. We got it covered, Jonathan. It works every time now.
Oh, the YouTube?
No, the hand raising.
Yeah, let me shut down the YouTube then.